Welcome to the MS SQL Tips webcast, Windows Server 2016 High Availability Options, what every SQL Server DBA needs to know, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips, and today's webcast host. Joining me today are Dave Bermingham and Tony Tomarchio, and they will share with us information about high availability options for SQL Server. Before we get started, if you have any questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the questionnaire to let us know. If you're not already a member of the MS SQL Tips SQL Server community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Thanks, Greg. So as Greg mentioned, my name is Dave Bermingham. I've been a Microsoft MVP for the past 6 years with a focus in high availability, SQL Server, and most recently Azure and Cloud. And so today's topic, we're going to be talking about what every DBA needs to know about working with Windows Server 2016, which is currently in preview, in the Community Technology Preview 4. And specifically, we're going to look at the high availability features that are new in Windows Server 2016 that will impact SQL Server deployments. So let's get started with that. So the agenda, we're going to take a look at how to get a hold of 2016 to start your evaluation process. And then there's a list of some of the features we're going to discuss and in some cases talk about implementation, including storage replica, cloud witness, site awareness, cluster rolling upgrades, workgroup and domainless clusters, and then storage spaces direct. So let's get started here. So how would you get a hold of the Community Technology Preview? So really there's two ways to evaluate it. You can get the download and install it on premise through this link here. You'll see you can get the eval copy, or also you can evaluate it in the Azure Marketplace. So if you want to spin it up in the Azure Cloud, it's a very simple way to get your hands on it without having, you don't have to have infrastructure in place to do the evaluation. And Azure actually has a free evaluation version. You can get about $200 worth of Azure credits to start kicking the tires. So let's take a look at what that means in Azure. So I'm going to jump out of the presentation here for a minute. And in case you've never seen Azure, it's pretty easy to work with. This is the Azure portal, portal.azure.com. Once you sign up for your subscription, you'll get a portal that looks something like this. I've kind of customized it for my use, but it's very easy to get started. Once you get your portal up and running, get your subscription, everything you want to create is basically kicked off by creating new, and you come out here and you see there's a whole lot of options. So in Azure Marketplace, we're going to go over here to New Compute, and we're going to choose this second option here. So you see, obviously, Windows Server 2012 R2 is the currently released version, the latest version of Windows. But you can also get the Windows Server 2016 Technology Preview. This one is the core only with containers preview. There's all sorts of options here, but just choose the version you want to evaluate, and that'll kick off the configuration process. Is pretty basic. I'm not going to go into great details. I had another webinar recently, I think it was last month, about configuring Azure's and Azure Resource Manager. You might want to check that out. But it's really click next, 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 and you'll have some Windows Server 2016 servers up and running pretty quickly. So it's very simple. Fill out the name of the server you want to create, username, this will be your administrative username, password you want to use for that, subscription you want to use, resource groups. Again, we're not going into great details about that, but you can create a resource group here, and the location where you want to deploy it, and okay, and then you have some options for creating virtual machine sizes. So all sorts of different sizes, different amounts of core, memory, and so forth. So you create that, choose your size. And different settings. You can have your different virtual networks. I've pre-configured a lot of this information by creating virtual networks ahead of time. But just give you an idea of how you can get started evaluating Windows Server 2016 without having any on-premise resources available. So let's jump back into the presentation here and move on to the first feature we're going to look at, and that would be the storage replica is the name of the feature, and we're going to focus on using storage replica for a multi-site cluster. Now, storage replica has a few different use cases, including just simple replication between servers, synchronously or asynchronously. But I think what you're going to see as a SQL Server DBA, or people are going to want to leverage storage replica to help facilitate multi-site clusters. This picture here is taken from the Microsoft webpage referenced down below here on TechNet. But essentially what's shown is a multi-site cluster where you have your traditional shared storage cluster in Redmond with the SRV01, SRV02, and they're connected to some sort of shared storage device. And that's a SAN, your iSCSI array. And so that's what you have today for a traditional, always-on failover cluster instance cluster. Now, if you wanted to have high availability and disaster recovery, you might consider implementing what's called a multi-site cluster, which has been around for a while. It was introduced, well, people have been doing it for a long time, but mainstream support for it was in Windows Server 2012 R2, and it's been enhanced ever since then. To do a multi-site cluster, you need some sort of mechanism to replicate the storage that's in Redmond to Bellevue. Now, traditionally, you had to look at either your array vendor to provide some sort of replication mechanism. So EMC has the SRDF, the cluster enabler solution that could do that, and pretty much any in the major arrays would have some sort of replication engine that could integrate with failover clustering. Or you could look at host-based replication solutions like the SIOS DataKeeper solution, which our sponsor will be talking about later. But that would give you a software-based replication solution that would enable you to create these multi-site clusters. Now, today, Microsoft, starting with Windows Server 2016, is going to give you another option to use essentially a host-based replication solution, software-based replication that's going to allow you to build a multi-site cluster such as here, where you have two nodes connected to shared storage, replicated to another two nodes in your DR site connected to shared storage. So some of the requirements for that multi-site cluster, they're leveraging SMB3 for the transport of that. And to get the best performance out of SMB3, you're going to want to use RDMA-enabled NICs. So the network supports RDMA or TCP. Again, for performance reasons, you're certainly going to want to use the RDMA-enabled NICs. Now, the biggest difference between the, I'd say, solutions like DataKeeper versus this storage replica solution is that storage replica requires a physical disk resource on each end of the replica. And because the failover clustering is going to require the physical disk resource to control the replication, the storage replica. So you're not going to be able to build a multi-site cluster that's based upon any storage that does not support SCSI3 reservations. So you're not going to be able to build multi-site clusters that are using, something like a Fusion IO, flash-based RAM storage, or even even virtual machines that are just using VMDKs or VHD files. The storage at each end has to support the SCSI-3 reservation. So that's one of the requirements there. And in addition to the storage, supporting SCSI-3 reservations, the replication does replication at the volume level. So you're going to have one disk that's dedicated for that you're going to replicate. You have one or more disks for replication, but you're going to need another entire disk that's going to be dedicated for the log file that the replication engine uses. So you're going to have multiple disks, some for storage, some for replication, some for the logs. And the limitation, currently is a single target. So you're going to only be able to replicate from one site to another. You can't have multiple targets. So you're limited to that single target. For the cluster integration piece, you have to use synchronous only replication. Now they do have an asynchronous option, which we're not really talking about here. If you want to simply just do data replication from one server to another without any sort of cluster integration, there's the ability to do that with asynchronous replication. But for the multi-site cluster, it's going to be synchronous only, which means you're going to have a pretty significantly fast WAN connection with minimal latency. And the preferred connection is 10 gig connection over iWarp or InfiniBand, and with a latency of less than 5 milliseconds with high speed. So at least a gigabit, but preferably 8 gigabits per second or higher is what Microsoft is currently recommending to enable this multi-site cluster. So some pretty significant investments there in your WAN and your infrastructure to support this multi-site cluster with the storage replica. But it works. I've used it and configured some of the replicas. Of course, it's we're still in the community technology preview 4, so they've been improving it with each release. But you can definitely check that out today. So, building on that theme of multi-site clusters, like I said, multi-site clusters have been around for quite some time, and leveraging storage replication or host-based replication solutions. One of the biggest gotchas with a multi-site cluster has always been in the quorum configuration. If you're not familiar with the Microsoft Cluster Quorum, essentially the mechanism that the cluster uses to decide which node comes online. And so quorum models consist of node and disk majority, node file share majority. They're the basic quorum models today. In a multi-site cluster, with any quorum, you need to have a majority of votes in order for your node to come online. So essentially, it's a voting mechanism. So what you see pictured here, again, is a multi-site cluster with 2 sites with 2 nodes in each site. And if the cloud witness is pictured in between. Now, before the cloud witness, we had to use a file share witness. And the file share witness was basically another Windows server that hosted the file share that would take part in the vote in the quorum. Problem is, the file share, in order to have a resilient cluster that supported automated failover, that file share had to sit in a third data center in order for automatic failover to work consistently and reliably. And that was a pretty significant investment if you were trying to do disaster recovery between 2 sites. Now you needed to have a third site to host that file share witness. And so what Microsoft has done is eliminated the need to have that third site by letting you leverage Azure blob storage to participate in the vote. So it doesn't even require you hosting a virtual machine in Azure. It simply requires you create a storage account in Azure and then leverage that storage account as a vote in the cluster. We're going to take a look at how to configure that. It's pretty slick, pretty easy. And the good thing is, it doesn't, at this point, it doesn't cost anything. There's been some testing done, and essentially the amount of storage you're using and the amount of I/O that is being generated does not even cause your storage account to round up to a single cent. So, keep that in mind. That's obviously liable to change, but it's not a very expensive solution for you to implement. All it's going to require is that each site has access to the public internet so they can reach the Azure storage account in question. Now, let's just take a minute to understand why this third location is important. If you picture a multi-site cluster, you have equal number of nodes in each location. Without any sort of witness, if we were to lose the entire site, let's say site 1 went offline. Now site 2, without a witness in place, we only have 2 votes out of a total of 4. It could not form a majority of votes. So it would never come online automatically. You would have to force the quorum online in order for the disaster recovery to take place. So by adding a witness, now site 2 plus this witness will have 3 votes, but 3 out of 5 votes would enable the cluster to come online. Now, if you were to say, well, why do I need that third node? Maybe I could just put that witness in site 1. So if you picture that scenario, again, if you lose site 1, you've lost the 2 cluster nodes plus your witness vote. So that's why putting the witness in the primary location is not a good idea, because you still won't have automatic failover to site 2, because you only have 2 out of 5 votes. And if I were to put the witness in site 2 and I had a failure of site 2, if you lost 3 votes simultaneously in site 2, site 1 would only have 2 out of 5 votes, and it would actually come offline even though everything's working fine and you didn't lose any cluster nodes. It would lose the majority and come offline. So by putting the witness in the second site, you're risking downtime associated with a failure of your DR site, which certainly is not a good idea. So that's why having that third location is always the best solution for any sort of multi-site cluster. And now Microsoft has made it easy for you to leverage the cloud as a vote in that cluster. So again, it's an alternate to a disk witness and a file share witness. So for any on-premise cluster that leverages shared storage, you're going to use what's called a disk witness, which is just another partition on your shared storage, which is going to act as a vote. Where the shared storage is not viable, such as in always-on availability groups or multi-site clusters, traditionally up till now, you had to create another server and create a file share that participated in witness. And so this eliminates the need to have that third server. So again, it's great for multi-site configurations. Also, I've seen over the years where branch offices want to create a simple 2-node SANLess cluster, maybe a 2-node Hyper-V cluster, or even a SQL cluster, and they didn't want to use a SAN, so they're leveraging some third-party replication solution like DataKeeper to build this 2-node cluster. But there always was this gotcha where the cluster was looking for a third vote, and so you always had to have that third server to have a file share witness, and that increased the overall cost of that deployment from simple 2-node cluster to now having 3 servers in each location. File share witness, we've eliminated Microsoft has eliminated the need to have that third server to just leverage the cloud witness as that vote. And in cloud deployments, where there is no shared storage, you're going to certainly want to leverage the cloud witness in any sort of cluster implementation, whether it's Azure or even Amazon EC2, where there's no shared storage. For the disk witness, cloud witness is a great alternative there. So I'm going to take a look. I recorded how to configure this, so it's a short little screen capture here. In the Azure portal, again, we're going to go and we're going to create a new storage account. So on data and storage account. And resource manager is fine, a class is fine. The big thing is you're going to give it a name. This name has to be unique within Azure. So pick a name that's going to be unique, and Microsoft will check that. Big thing here is the storage account type needs to be local redundant. It will not support geo redundant. It has to be local redundant. So you give it a resource group name, and you create that storage account in whatever location you want. Probably preferably close to the location where your cluster is going to be. And once that storage account is created, you're going to want to go into the storage account and get some of the information. So it's Dave's Cloud Witness is the name of the storage account. But then within there, you're going to look at the access keys. And you're going to need this. You're going to copy one of these keys because we're going to use it when we configure the cluster. We're going to create a Cloud Witness. So I copied that key. I'm going to jump over to Failover Cluster Manager. And I have a cluster pre-configured that currently has no witness. I'm going to show you how to configure this Cloud Witness. Pretty simple. You right-click, More Actions, configure the cluster quorum settings. And we'll walk through this wizard. We're going to actually select a quorum witness. And this is where you'll see the new Cloud Witness is now an option. So we'll choose that. And again, very simple. Paste that storage account key that we copied from the portal. Type in the name that we of that storage account. So Dave's Cloud Witness was the name we used. And that's it. Click Next and Next. And that's it. It's created that Cloud Witness. And you'll see in the cluster now, it has the witness as a Cloud Witness. Very simple process, and it works well. I've been using it for ever since it became available. So it's a great solution here. So let's jump back into the presentation. So building upon the multi-site cluster. So we saw storage replica, which is great. It's going to give you the storage solution to build those multi-site clusters. And then the Cloud Witness is another thing that's going to facilitate the multi-site clusters. The next feature that Microsoft has introduced is something that I've been asking for since I can't remember when, is site awareness. And what site awareness basically does is it allows you to specify, in the example we saw, we have 2 data centers. You can specify which nodes run in, the primary data center and which nodes run in the secondary data center. Before that, there was really no way for you to group your cluster nodes by data center. You could use something called preferred owners and possible owners, and you could try to mimic what site awareness is doing, so that the bottom line is, if you have a multi-site cluster, you never want your cluster nodes failing over to the DR site unless it's truly a disaster. And before site awareness, it was very hard to guarantee that you wouldn't accidentally fail over to the DR site, even though there were nodes available in your primary site. Again, you could try to force that through preferred owners, but there was never any guarantee that preferred owners list wouldn't choose the DR site when one of the local nodes was still available. So by configuring site awareness, you're going to eliminate that so that the resources will run locally whenever possible. And you can get some more information about configuring this. All this information I'm giving you today is pretty well documented on the Microsoft blogs and TechNet, and the documentation available with Windows Server 2016. I just want to give you a general overview of these features. But let's take a look at how to configure site awareness. Configuring site awareness, it has to be done through PowerShell. And here's an example where I have 4 servers. 2 servers called SQL 1 and SQL 2 in my primary site, and then 2 servers in my DR site are called SQL 3 DR, SQL 4 DR. And so I'm setting the 2 local sites, SQL 1, SQL 2, I'm setting that to site 1, and then SQL 3, SQL 4, I'm setting that to site 2. So I'm grouping them into sites to ensure that the sites always fail over to within the same site before failing to a node in a different site. And so that's step 1. You got to assign the nodes to the specific sites. And then once you have the sites once you have the sites configured, you can assign a preferred site. And the preferred site is essentially going to allow you to control how dynamic quorum controls which sites get votes. We're not going into great detail. Microsoft has been making some improvements to the quorum mechanism, starting with Starting with Windows Server 2012, it had something called dynamic quorum, which would allow the quorum, the number of votes to be updated dynamically. And so it essentially tries to ensure that you always have an odd number of votes in your cluster. And with 2012 R2, they also introduced something called dynamic witness, which again controls whether or not you have, whether or not the witness has a vote. The goal is to always have an odd number of votes so that you never have a split cluster with just an even number of votes on each side. And by assigning the preferred site, it will always remove the votes from the DR nodes whenever the dynamic quorum updates whether or not a node has a vote. It will drop, if needed, it will drop the vote from the nodes in the DR site. So again, that ensures that the failure of your DR site should never impact the availability of the nodes in your primary location. So again, for multi-site clusters, this is great. You're going to want to certainly configure this in your environment. Another benefit of configuring site awareness is that you can also control the cluster heartbeats between sites. So there's a new option here where you can configure the cross-site delay and cross-site threshold. Essentially, the delay is how often do I send a heartbeat, and then the threshold is how many heartbeats can I miss before I determine that a node is actually offline. And so, each time a node is removed from the cluster, right, it potentially impacts the availability of your application. And so you don't really want your cluster nodes dropping, coming in, coming out on any regular basis. Each time that happens, the dynamic quorum needs to, update the quorum count, the witness, dynamic witness will be updated. So if you have a WAN connection that maybe is not entirely, reliable, or that it has dropouts occasionally, by adjusting these cross-site delays and cross-site thresholds, you can essentially, relax the policy so that you can have, an extended outage of your WAN link without actually impacting the votes in your cluster. The very fast, the standard setting here without any sort of changes would be, send a heartbeat every 1 second and that's 5 missed heartbeats. That will affect the votes in your cluster. You certainly want to tune that up for your WAN to have a much more lenient policy there. So let's take a minute here. Since we're talking all about multi-site clusters, just kind of curious how many people out there have implemented a multi-site cluster. And this could be, an always-on availability group cluster, stretch between sites, or failover cluster instance leveraging, array-based replication or host-based replication. So, Greg, if you want to bring up the poll question, I'd just be curious to see, how many people have implemented multi-site clusters.
We have a good amount of people voted so far. I'll just give another 20 seconds here. I'll
All right.
The results.
Yeah, if you haven't implemented a multi-site cluster, and you're thinking about disaster recovery, there's lots of options. You think about disaster recovery. The biggest thing people think about is, recovery time objective, recovery point objective. How much data can the company stand to lose, and how fast do I need to have things back up and running in the event of a disaster? The multi-site cluster is essentially going to, is the Cadillac of DR solutions. You're going to have, if you implement synchronous replication, you're going to have 0 data loss. Of course, the network requirements are pretty stringent on that, as we saw, but that's recovery point objective of 0 data losses. You can't get any better than that. Recovery time objective, for a cluster to fail over, or even an availability group to fail over, you're talking seconds. So your recovery time objective is very quick as well. So if disaster recovery is on your plate for this year or coming soon, multi-site clusters is certainly something you're going to want to consider for your disaster recovery plan.
All right, I'm going to close this and I'll share the results. So we have 29% said yes, 50% said no, and 21% planning to do in the future.
All right, that's good to know. Yeah, multi-site clusters are, like I said, great solution for DR. Not always possible, because of the bandwidth requirements and so forth, but certainly something to look at if you can. All right, so let's move on. Moving out of the multi-site clusters and all the features surrounding that. We're talking about another great new feature coming in 2016 is this cluster rolling upgrade. Now, prior to 2016, if you wanted to upgrade your operating system of a cluster, this is any cluster from Hyper-V to SQL Server or anything, you essentially had to start new. There was no way to upgrade an existing cluster. You had to either buy some new hardware and create a new cluster, then migrate your databases and migrate your clients to the new cluster access point. So that's kind of the way you had to do it. And so with 2016, you're now going to be able to upgrade the cluster in place. I'll say in place. This picture I have here is taken from the documentation that on TechNet, which shows you the process. And we'll walk through the process. So you have to start with the Windows Server 2012 R2. So you're not going to be able to upgrade from anything earlier than Windows Server 2012 R2. So you're not going to be able to upgrade 2008 clusters directly to 2016. But assuming that you have a Windows Server 2012 R2 cluster, obviously you want to back up, do your backups of your cluster database, your workload, and make sure all your clusterware updates are applied into the cluster. Once you've done that, you're basically going to upgrade one node at a time. So the one node that you want to upgrade, you're going to pause that node and make sure that there's no roles running on that node at that given time. You're going to then evict that node from the cluster. For SQL Server, you're going to uninstall that node from the cluster and then evict it from the cluster. And then you're going to wipe that server that you evicted from the cluster. You're not going to be able to, it's not recommended or supported to do a simple upgrade from 2012 to 2016. You want to do a clean install on that server. So you're going to format the system drive, install the Windows Server 2016. Once that's installed, you're going to add the failover clustering feature to that node, configure the network and storage, and once again, if you're talking about the shared storage, you obviously have to connect it back to the shared storage, and then add that node to the cluster. You're going to install SQL just like the first time around. You're going to have to install SQL by adding a cluster node, and once you've done that, the workload can now fail over to that node. So you're going to fail over to that workload. Make sure to that new node. Make sure that everything's working as you see fit, and then you're going to upgrade all the other nodes in a similar fashion. And then once you're done doing that, finally run a command to update the cluster functional level. Once you run that command to update the cluster functional level, that's the point of no return. You wouldn't be able to roll back to 2012 R2 at that point. And so that gives you the ability, if things didn't go so well, you didn't like the way that 2016 was working for you, you always had the option of moving back to 2012 R2 until you run that final update. Now I'd say, as with many new cluster features, Hyper-V was really the target role. For SQL Server, when it wasn't a huge deal upgrading clusters. Generally, you update it less often, and the smaller amount of nodes need to be updated. Imagine that you're running a Hyper-V cluster with 12 nodes all participating in one big Hyper-V farm. If you wanted to go to the latest operating system, that was a pretty major undertaking. Now you could just do one node at a time until you got them all updated, and it's a pretty seamless process. So that's a great new feature that's coming in 2016 that you definitely want to check out. Speaking of 2016, again, another poll. Just kind of curious to see how soon people plan to implement Windows 2016. I know, Microsoft hasn't announced the general availability, but given the name, I assume that we're going to see this in this year at some point. So curious to see, what your plans are for moving specifically your SQL Server workloads to Windows Server 2016. So let's take a minute there and let me know your thoughts on that.
All right, just another 15 seconds. We'll close this poll and share the results.
All right.
All right, I'm going to close it, and I'll share. So we have 40% within a year of general availability, 37% after has been out for more than a year, 23% no plans to implement, and 0% already running.
Right. Okay. That sounds about right. That sounds about right. So one other feature, and this is an interesting feature. They're essentially going to let you build clusters without a domain. So prior to 2016, one of the requirements to build a cluster was each cluster node had to be in the same Active Directory domain, and so that was a requirement that was table stakes to get into clustering. Now you're going to be able to build a cluster with each node in the workgroup, or even between domains. And so it's going to eliminate the need for Active Directory. And so I'm kind of, it sounds neat, and I've heard some people talk about this. I imagine if you have an environment where you're not running Active Directory, maybe just a small shop, or you're not running a lot, you have a mixed environment with a lot of Linux and Unix, and Active Directory just was never implemented, but you all of a sudden you have this need to run this SQL Server workload, and you don't really feel like implementing Active Directory to have a highly available SQL Server workload. This could be a great alternative for you. You can do this within the domain. I'm not going to go into great details about how to configure this. All the information is readily available on the blogs at this link here at the bottom here. But essentially, you're going to create user accounts that are going to have the same name and password on all the servers. They're going to be, that account's going to be part of a local administrators group. And then they're going to create a cluster using this command new cluster with the administrative access point of DNS. So again, not going to go into great detail here, but kind of curious. Do people see a need for this, or is this something that you see yourself ever using? So let's take one minute. This will be the final poll. Just kind of curious to see what kind of update this might be. And I've seen over my years, I have seen this demand, and today when people need this kind of cluster workload without Active Directory, they're generally looking at third-party alternatives for clustering. So there's a few cluster solutions out there, including the one SIOS has been selling for years, the SIOS Protection Suite, which would work in Workgroup. But now that Microsoft's offering it, I'm kind of curious to see who would leverage that in a workgroup.
All right, I'm going to close this and I'll share the results. So 52% said yes and 48% said no.
All right, that's more than I thought, but that's good to know. That's why I asked. All right, and finally, one of the most interesting new features coming out with Windows Server 2016 is the Storage Spaces Direct, or S2D. This is an acronym right here. And this is a picture taken from TechNet, the documentation that shows the hyperconverged stack. Essentially, it's going to be a combination of storage and cluster workloads running on the same servers. I think the target here is your scale-out file servers and your Hyper-V virtual machines, which are pictured here. What it does is it's going to let you build a Hyper-V cluster without a SAN. And as you probably traditional clusters require some sort of shared storage device. but they're going to allow you to leverage local attached storage in each cluster node, and through the magic of SMB and replication, are going to keep the storage in sync and redundant spread across all the nodes in your cluster. It's going to require a minimum of 4 nodes in the cluster, and that's so that, you know, if you lose a single node, you still have redundancy across the other 3 nodes. So 4 nodes is the minimum configuration in CTP4 that you're going to be able to build this on top of. But you know, so you have the storage underneath, and then you can run the Hyper-V right on top of that through storage pools, storage spaces, and cluster share volumes. So it's lots of great, you know, great functionality. I think if you are looking at implementing a Hyper-V farm, you certainly are interested in this to as a possible storage solution rather than a SAM. Not going to go into great details about the configuration. All the details are in this link here, but you should be aware of it. But here are some of the requirements. So it's not something you get into lightly. There's a blog article that talks about the hardware requirements. But the big thing here, the second bullet, is there's going to be a group of vendors that are going to have hardware that's been certified and tested to work, you know, very well with this. So that's their recommendation, is that you purchase hardware that's been validated to run this type of workload. Some of the other requirements are listed here: the processor family, the network cards, records all the replication between the different instances, very fast networks, 10 gig networks with RDMA, you know, with you know, 2 high performance devices and capacity devices, lots of storage in each server as well. So again, something interesting you're definitely going to want to check out. You know, Hyper-V, more of a workload. You know, in theory, you could run SQL Server cluster in that, a 4-node SQL Server cluster. So something you certainly want to have a look at. So with that, I want to allow some time for SIOS to tell you a little bit about their solutions for you know, multi-site clusters and how they work today with Windows Server 2012 R2. So I'm going to introduce Tony Tomarchio from SIOS Technology.
Yep, and then once Tony's done, we'll get to some of the questions that people have asked. Take it away, Tony.
Yeah, excellent. Okay, great. Thanks, Dave. Thanks, Greg. Let me go ahead and show my screen. And I've got a couple of slides here, and then I'm going to take you into a demo of our DataKeeper product here. So let me put this into screen share mode here. We'll get right started. We'll get started here. So my name is Tony Tomarchio with the field engineering team here at SIOS, and SIOS has been around, formerly known as STLI Technologies, since 1999, really focusing on high availability and data replication solutions here. And you know what we're talking about here is the whole concept of SANLess clustering, or more specifically, shared nothing cluster architectures. And while most commonly customers are using this type of a technology for SQL Server high availability, basically to eliminate the shared disk requirement from a failover cluster instance of SQL. You know, this can be used for, you know, really any other clusterable service or application, and this applies to physical environments, to virtual environments, and then also to the cloud as well. So you've got a lot of flexibility. You know, this type of a solution is server and storage agnostic. So, you know, as Dave mentioned, some of the new features that are coming out in 2016, you have some pretty strict and steep, you know, hardware, storage, network requirements. So this, you know, if you need a little bit more flexibility, if you don't want to have to deal with some of that, you know, this is an excellent way to kind of get the best of both worlds with your high availability needs here. So, you know, as Dave mentioned, you know, the traditional failover cluster looks something like this. You've got a couple of servers with some type of shared storage, and that's how Windows Server failover clustering works right out of the box. Works great, but you know, the shared storage generally represents cost, complexity, and it's also technically a single point of failure. If the shared disk has an issue, it can take down your entire cluster. So when DataKeeper is involved, specifically we're talking about our product called DataKeeper Cluster Edition. So DataKeeper provides continuous real-time block-level replication between nodes. It's host-based replication software here. So think software RAID 1 mirroring going across the network. We've fully integrated it with Windows Server Failover Cluster, so if and when you do have a failover or between cluster nodes, it will automatically switch the direction of replication here. It also works in a lot of different configurations. You're not limited to just 2 nodes or a single target. You can have multi-target replication. Perhaps you want to have 3 nodes at 3 different data centers, something to that effect. You can certainly achieve multiple target replication, multiple nodes. These could be in the same data center, could be in different data centers. These even could be mix and matched physical servers, virtual machines, and even systems up in the cloud here. So really the only requirement is that your volume letters and sizes match, and aside from that, you can really use whatever server and storage you want. And of course, with any configuration through the integration of DataKeeper with failover clustering, the direction of data replication is always handled automatically. So whenever you fail over to a new node, that new node becomes a new source and it replicates to the other systems in the cluster. This is a great solution for SQL Server, for if you want to create a highly available file share, for custom services or applications. You also can use this if you want to do a shared nothing Hyper-V cluster. Again, any clusterable service or application, the way you achieve HA for Hyper-V is through Windows Server failover clustering, just like you do for SQL or any other service or application. DataKeeper also gives you flexibility in you can mix and match storage configurations. So perhaps you have an existing failover cluster with shared storage and you've got a physical disk resource and all that, and maybe at your secondary site you have a standalone system. Maybe you don't have a secondary SAN, you're just using internal storage, so it's not something that'll support SCSI 3 reservations, so you can't take advantage of storage replica. There's a number of different situations. Maybe you don't have a secondary data center but you want DR. Perhaps you want to leverage the cloud. So this gives you a great way to achieve that. This diagram is what I would call a 2x1 cluster. 2 nodes with shared storage replicated to 1 node with its own independent disk here. So again, it all comes back to flexibility in your cluster configuration options, your hardware choices, and a lot of that can end up leading to significant reduced cost here. So. We have a lot of customers who do clusters up in Azure completely. They're moving workloads completely up to the cloud. As Dave mentioned, this is what a cluster up in the cloud looks like today with 2012 R2 or earlier. So here I've got a file share witness. New with 2016, you'll have the option to do this with a cloud witness. So these could be two virtual machines in a VMware on-premise, could be 2 physical servers. These could be 2 systems up in AWS or Azure. You eliminate the need for that third system here, and you can use a cloud witness. So now we're kind of getting short on time here. So what I'm going to do is actually jump into a demonstration, show you what this looks like, and then we'll have about 10 minutes for Q&A at the very end. So let me switch modes. I'm going to bring up demo environment, and we'll take a look at DataKeeper. Okay, so here I have a run-of-the-mill Windows Server failover cluster. And within this cluster, I've actually got 2 different cluster roles. So I've got a highly available SQL Failover Cluster instance, or SQL FCI here. And if I take a look at the resources, let me scroll this up. This looks and feels and acts just like any old cluster. I've got my network name, my virtual IP, I've got my SQL resources that it's controlling. And then here's where things get different. So in your traditional shared disk configuration, I would have, as Dave mentioned, it's called a physical disk resource. That's basically your shared LUN on the SAN. Well, when DataKeeper is involved, we are providing what's called a third-party storage class resource. So we've got a DataKeeper volume resource, which looks and feels and acts like it was shared storage. But in reality, I have an equally sized S volume. So my cluster nodes are called SIOS 1 and SIOS 2. They each have a matching S drive. DataKeeper is performing the real-time replication to keep the data synchronized, either synchronously or asynchronously, depending on generally if you have a high-speed, low-latency network connection, it's always best to go synchronous. If you're doing this with one node in San Francisco and the other node in New York, and you've got 80 milliseconds of latency between the two, then it might be more appropriate to go with asynchronous replication in that case. So here I've got this DataKeeper volume resource, and this fails back and forth along with the SQL Server. I also do have a highly available file share as well, just to illustrate that, again, this can be used for any clusterable service or application. So here, if I look at the storage cluster disks here, I've got these DataKeeper volume resources instead of your traditional shared disk resources. And just really quickly, in about 1 minute, I'll show you how we create this, and then we'll open things up for Q&A. So the way that you get the DataKeeper resources into the cluster is through the DataKeeper UI. Very easy to use. It's a 3-step wizard to create a mirror. So here I've got an R volume, and I'm going to create a new mirror and have that be added into my cluster as a cluster disk. So I'm going to go in here, give it a name, call it R drive, and go through a 3-step wizard where I select my source, my target, and finally my mirror options. So my source will be SIOS1. If you have multiple network interfaces on your systems, you can decide which NIC is going to be used for replication. And as a best practice, it's always a good idea to separate your replication traffic from your normal client traffic if possible. And then I've selected the drive letter that I wish to replicate, in this case R. If I click Next, step 2, I select my target. Now there's nothing to change here on this screen. It's automatically selected the other machine, the appropriate IP, and the same drive letter. And then finally I can specify my mirror options. Here I'm going to put this into synchronous mode because these two cluster nodes are on a local area network, so I've got high-speed, low-latency network connection between them, and click Done. So that's it. Simple 3-step wizard to create this new mirror. It's going to replicate the contents of R from SIOS1 to SIOS2, and because DataKeeper is cluster aware, it's asking me right now if I want to register this new DataKeeper resource with failover clustering. So I'm certainly going to say yes here. And now if I go back into Failover Cluster Manager, I have this brand new DataKeeper volume R sitting right there in the cluster's available storage pool. And at this point, this is really just clustering 101. You use that DataKeeper volume resource like you would your traditional cluster disk here. You add it to your role, you install SQL Server, your new instance of SQL Server, you go through the wizard, and halfway through that wizard where it asks you which cluster disk you want to use, you simply check the box next to the DataKeeper volume resource here, and that's it. And just to show you how things fail over, again, this doesn't change the behavior of your cluster. Maybe I want to fail over my SQL Server to the other node. I'm going to go ahead and fail that over to SIOS2 and click OK. And it's going to bring everything offline on SIOS1, bring everything back online SIOS2. That takes just a few seconds here. And also as part of this, it's failing over the DataKeeper volume resource, which under the covers is switching the direction of replication, and it's flip-flopping the source and target roles. So here for my DataKeeper volume S, I can see that now SIOS1 is the target where it used to be the source, and SIOS2 is the source where it used to be the target. So this is staying in sync with what's happening with the cluster. And notice I didn't have to go and touch anything within DataKeeper to make that happen. So that's just a brief demo on DataKeeper. Again, it's a simple 3-step wizard. This is a great way to eliminate the shared storage requirement from a failover cluster, whether that's clustering up in the cloud or in virtual environments where shared disk isn't available or practical, or if you want additional flexibility in some of the hardware and cluster configuration choices that you have, given some of these new features coming out in Windows 2016. This is still a great way to achieve HA if you can't meet those requirements for some reason here. So with that, I guess, Greg, let's go ahead and open things up for questions. And while we do that, I'm going to bring up a final slide. If you have questions, if you want to get more information, you can always visit us on the web at us.sios.com or email info@us.sios.com. We also do have a couple of upcoming events. March 17th, we're doing another webinar, live Q&A about HA in the cloud, and then also we'll be, for those of you who are going to go to SQL Saturday in Boston, come visit us on March 19th as well. So, Greg, let's go ahead and open it up for questions.
Okay. This question goes back to the Cloud Witness, and the question was, what happens if Azure goes down or they're not able to connect to Azure? Does that affect the Cloud Witness?
Yeah, so Cloud Witness obviously requires that Azure be up and running and your storage account be available. The good thing about Cluster is, you have redundancy. So losing a witness does not impact the availability of your cluster, especially with Windows Server 2012 R2 with Dynamic Witness and Dynamic Quorum. As long as your cluster can always maintain a majority of votes, everything's going to continue to work fine. So in the case we saw earlier where you had 2 nodes in the primary, 2 nodes in the secondary, and the witness in Azure, if you lost Azure for a period of time, you know, everything would continue to work. You still have 4 out of 5 votes in your cluster. And what would happen if you configured things right, if you configured your site preference so that your primary site was the preferred site, what would happen actually is your Azure vote would go away, and that leaves you with 4 votes in your cluster with no witness, right? Now Microsoft doesn't like an even number of votes in your cluster, because if you lose 2, you're going to come offline because 2 out of 2 is not a majority. So what it does, dynamic quorum would actually remove a vote from one of the nodes in the DR site. So now you would have 3 votes in your cluster, 2 in the primary, 1 in the DR site. So you could still, you know, and that would continue to update dynamically if you would continue to lose votes. You could actually, if configured properly, you could actually get down to a single node still running and still be up online. So that's the great benefit of dynamic quorum and dynamic witness that Microsoft has introduced over the past 2 releases, that you could actually get down to a single node and still be up and running. So yeah, we expect that, you know, you're going to lose something along the way, but losing a single vote in a quorum is generally not a cause for downtime.
Okay. Another question, Dave, is does site awareness restrict the presentation of clustered share volumes?
Site awareness, again, that link that I mentioned is going to have a lot more detail than I went into. So site awareness also does impact cluster share volumes and where they're running, where they're accessible. So, you know, I don't want to speak on the topic with any great detail. I haven't used it with CSV yet, but I know that it does control where the CSV is being, you know, the primary node for that CSV. So definitely you're going to want to check that out. And you probably get the answer to your question right there on the Microsoft documentation page.
Okay. The next question, Dave, is related to the rolling upgrades. And the question is, does this mean that there's no way to upgrade from 2012 R2 to 2016? And do I have to reinstall other applications such as SQL?
Mm-hmm. Yeah, you're going to have to. So the process is a complete reinstall. So yeah, I mean, it would be nice just to pop the disk in, you know, each node and say, make this, you know, make this cluster 2016. It doesn't quite work that way. So you do have to reinstall SQL on each node as you upgrade it. So the process again is evict one of the nodes, flatten it completely, format hard drive, install Windows 2016 on that node, install Failover clustering, add that node to the cluster, install SQL on that node with the add cluster node installation, and now you have a mixed node cluster where you're running 2012 R2 on one node and 2016 on the other. When you're ready to upgrade the other node, fail over to the 2016 node, again evict the other node from the cluster, flatten it, install Windows 2016, install SQL. So yeah, it's a process involved. There's no direct upgrade path. You're going to have to go through that process of reinstalling your applications.
All right. Another question, Dave, is related to cluster-aware updating. And they're just wondering, is this supported on a failover cluster running always-on availability groups when updating the operating system?
Yeah, I'm not aware of any restrictions there, so I don't want to say, you know, 100% for sure. I'm not exactly sure what the question is, but cluster-aware updating has been around for a while, so again, I'm not aware of any restrictions there. So probably want to, you know, check that out on the forums for sure to get a definitive answer.
Okay. The next question is related to the multi-domain support, and can you just kind of clarify that? They're just a little confused exactly. What do you mean by multiple domains?
Where one, so I see this scenario, again, you know, I'm trying to imagine this in my head. That's why I asked the question of who sees the use for this, because I didn't think it would be quite 50%, but that's good to know. Multi-domain is you might have acquired a company, let's say you merge with another company. They have their own Windows domain, and you have your own Windows domain, and there's no trust between the domains, and it has to remain that way for regulatory reasons or whatever. But you'd love to be able to use their data center as a DR site, right? So now you could actually configure a cluster that one node resides in your data center, in your Active Directory domain, and another node, or maybe just a DR node. Maybe you have two nodes locally in your domain, and then one node is going to reside on a server that sits on their network in their domain. Again, to me, it's a stretch in the imagination. Like, why wouldn't I just, add another server in my domain? But the option's there. So that's what that means. Multi-domain just means that each server can belong to a different domain that has no trust relationship whatsoever, and you could still build a cluster between those domains. You just have to have a local administrator account on each server that has, same name and same password on each server.
Okay. The next question, Dave, is related to 2016 storage replica, and just wondering, does this work on AWS? And they said that I assume it doesn't work because the SCSI 3 reservation support requirement.
Yeah, that's the biggest thing. It's kind of disappointing that it requires physical disk resource, so you're limited to scenarios where each node is attached to. Generally, you're talking about being attached to a SAN, some fiber channel SAN, or some iSCSI target. They're usually the storage types that are supporting the SCSI 3 reservations. So yeah, AWS or Azure, you're not going to be able to leverage storage replica to create a SANLess cluster. You have to continue looking at the solutions out there like DataKeeper, which doesn't require, can work with any sort of disk. It doesn't require any physical disk resource or SCSI 3 reservations.
All right, let's see. All right, the next question, again, is just kind of your opinion, thoughts on sort of high availability options for SQL. Any sense of kind of what the direction is for the future? Are people going to go more clustering, mirroring, replication? Any thoughts on kind of what you're seeing out there?
Well, as you've probably seen, Microsoft starting with, Exchange database availability groups, and SQL database mirroring has been around for quite some time. People have realized that shared storage, although can be reliable, it really represents, at the end of the day, a single entity that could fail and bring down all your cluster nodes. So with storage replica and storage spaces direct and all these new technologies for replication, you can kind of get the idea that Microsoft is leaning away from shared storage as a cluster solution. So I think all the replication solutions that are coming out and all the third-party replication solutions are really the wave of the future, especially when they start looking at cloud. And I see cloud being really the biggest opportunity, where we saw, from physical to virtual, that migration took some time, but now people are generally, majority virtualized, if not 100% virtualized. Cloud, I see the same scenario, where people are now starting to leverage cloud more and more and doing away with their own data center. So in the cloud, you're certainly not looking at shared storage clustering. You're looking at alternatives to that, including the replication solutions out there.
Okay, Tony, this question's for you. It looks like somebody on here is using another product that does replication and over a WAN geo-clustering replication, and they just said they're not really impressed with the speed and the time that it takes to fail over and so forth. They're just wondering kind of some of the advantages that DataKeeper has for the replication.
Yeah, oh, definitely. So the first thing is, the DataKeeper doesn't really affect the failover time, right? That's all controlled through Windows failover clustering, so that's not going to be impacted by having DataKeeper in place. Now, where you're going to see benefits is, a lot of solutions out there are doing file level replication, unless you're doing this kind of at the array level. So most solutions out there are doing file level replication, which generally has a lot more overhead because you're worrying about things like locked files, open files, file permissions, things, checksums, things like that. Whereas with DataKeeper, we have a really efficient replication engine that's been implemented as a filter driver, so it sits right beneath NTFS and essentially just intercepts writes as they come down. One copy of the block goes to the local disk, and the other copy gets sent across the network. And we've done a lot of work over the years to really optimize the replication engine. We have a lot of customers who use high-end storage devices, things like Fusion IO cards that can write just at insanely fast speeds, and they want a replication technology that can keep up with that. Also, we've done a lot of comparisons, with DataKeeper versus the performance of always-on availability groups, and see that DataKeeper can replicate data faster between point A and point B. And when you're talking synchronous replication, what that translates to is less slowdown of your primary server. So you don't want your HA solution to negate the benefits of the faster storage that you've allocated to your servers. So if you're unhappy with your current solution, I definitely do encourage you to reach out to SIOS, and we can have a more in-depth discussion, see what you're dealing with here. Go ahead and either email info@us.cs.com, or you can email Tony and we'd be happy to help you out.
Okay, we'll take 2 more questions. We're a little over time, and then we'll wrap things up. So one question somebody asked was, is it possible to use the other node for read-only applications? So when you're replicating data with DataKeeper?
DataKeeper, sure. So DataKeeper does have a target snapshot feature. So what that does, it allows you to access data on the target of the standby system, a point-in-time copy of data. So the kind of use case with that feature was doing things like offloading your nightly reporting or your backups to a standby node in the cluster. So it is point in time, but you can drop the snapshot, take a new snapshot, perform your activity, drop the snapshot afterwards, and so on, things like that. So it's not continuously updated in real time. It is point in time, but you could, for example, schedule the taking and the dropping of the snapshot.
Okay, and the last question here, Tony, this is for you as well. Again, another question related to another competitor's product. Again, replicating over WAN, they actually had corruption with the replication, and they said because SQL, it wasn't transaction aware in SQL Server. So just wondering, can you kind of explain how SIOS works, DataKeeper works for that?
Sure. So while replication is taking place, you have write order consistency. So the blocks are going to be written on the target in the same exact order that they're written to on the source. Now, with asynchronous, there could be the target might be slightly out of date, so it might be a handful of writes behind, but you still have that write order, that crash consistent data on the other end. It's just might be a second or a couple seconds behind. So you're going to be able to still bring up your SQL database on the other side. It might have to roll back a transaction or something. Think of a situation where if you had a standalone SQL Server and it was in the middle of a write and you kicked the power cord and the thing died in the middle of that, right? Well, when SQL comes back up, it knows how to recover from that situation. So you have the same crash consistency, write order consistency with DataKeeper. With synchronous, of course, there's zero data loss. If you go with asynchronous, there could be a little bit of data loss. It might be slightly behind, but you still have write order consistency.
All right, great. Well, thanks, Dave, and thanks, Tony, for sharing all that great information. And also want to thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive and also download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thanks for attending, and have a great day.